This is lesson 8.5, part 3, simplifying a complex fraction. Complex fraction is where you've got a fraction in the numerator and a fraction in the denominator. We're going to work it similar to how we did when we added and subtracted rational expressions. The first thing that I want to do is make everything involved here into a fraction. I'm going to change my whole number into a fraction by dividing by 1. So 1 over 1 and 4 over 1. I like to rewrite these in horizontal. It's easier for me to look at and find the common denominator. So I'll go 1 over 1 plus 2 over x and group those as the numerator, divided by 4 over 1 minus 6 over x, and group those together as my denominator. So I need to come up with a common denominator that's true for all 4 fractions. That common denominator is going to be x. If I look and see what they have in common versus what they don't, I can see x and 1. I know that if I multiply this first fraction by x over x, 1 times x is just x. I can do the same thing here with the second fractions. 4 times x over x, and again 1 times x is just x. Now all 4 fractions have that x as their denominator. So for my first group, the numerator, I have x plus 2 all over x divided by the denominator, 4x minus 6 all over x. Now we're going to divide fractions. When we divide fractions, we flip the second fraction and multiply. So I take my first fraction, x plus 2 all over x times the x is now in the numerator and 4x minus 6 is in the denominator. And now I cancel. X and x can cancel, bringing me to x plus 2 all over 4x minus 6. Now it starts to get good. We get to factor anything possible. I can't factor the numerator, but I see in my denominator they have a GCF of 2. So I can factor out that 2. That gives me 2 times 2x minus 3. Our next step would be to cancel if there was anything to cancel, but I can't. And that gives me my final answer. It didn't ask me to state any restrictions, so I don't have to do that in this particular problem. All right, so let's talk about the different steps that we took. The first step we took, we wrote everything as a fraction. We took all whole numbers and wrote them as fractions. The next step we took, we found the common denominator of all 4 fractions. With the common denominator, we wrote the numerator as 1 fraction and the denominator as 1 fraction. Then we divided the 2 fractions. You take the second and you flip it and multiply. After that, simplify. Cancel if we can, factor if you can, cancel some more. Let's try these steps here on our last example. 5 over x plus 3 divided by 2 plus 1 over x plus 3. The first step was to write everything as a fraction. So I'm going to take my whole number 2 and make it 2 over 1. So I'm just going to rewrite these horizontal. 5 over x plus 3. I have a single fraction in my numerator. Divided by 2 over 1 plus 1 over x plus 3. So 2 fractions make up my denominator. My common denominator is going to be x plus 3. They all have it except for the 2. So I'm going to multiply this by x plus 3, both top and bottom. Coming down to my next step, 5 over x plus 3 doesn't change. Divided by 2 times x plus 3 plus 1 over x plus 3. That's my denominator now. I've combined them into one fraction. Let's distribute this. It'll give me 2x plus 6, and then add the 1. That was 2x plus 7 divided by x plus 3 is now my denominator. I want to flip the second fraction, so x plus 3 goes on top over the 2x plus 7 comes down. They're both binomials, so let's put them in parentheses. When you divide fractions, you flip that second and multiply the two together. 5 over x plus 3. Cancel, cancel, cancel. I have x plus 3 in the numerator and denominator. I can cancel both of them, which gives me 5 over 2x plus 7. Nothing can be factored, nothing can be reduced. That is my final answer. If they ask you to state restrictions, you need to go back through the problem. Anytime something was in the denominator that involved x, that would be a restriction. So let's look. I have my x plus 3 in the denominator. So that tells me that x cannot equal negative 3. Negative 3 plus 3 would be 0. And I'm looking to see what else I've got. Down here in my last step, I had 2x plus 7 in the denominator. So 2x plus 7 also cannot equal 0. Subtract the 7. 2x cannot equal negative 7, and divide by 2. If they ask you to state restrictions, look back. Anytime something was in the denominator, you need to restrict it. So x cannot equal negative 3 or negative 7 over 2. And that would be your final answer.